So this tutorial is a conceptual or qualitative explanation of what these stoichiometry problems are doing. Okay, so if you watched the previous video, you saw how we solved them. So now I'm going to explain. So in the first question, it asks how many moles of oxygen would be needed to produce 3.3 moles of carbon dioxide. Okay, so if we look at our recipe, what we're saying here is we want to know how much oxygen we need to put in if we want to make a different amount of carbon dioxide. So if you think about it in terms of a recipe, let's say you wanted to adjust your recipe so you made more cookies. Okay, so if you wanted to make more cookies, you would also have to use more of each of the ingredients. Okay, so in this case, the ratio of coefficients tells us that for every 5 moles of oxygen, 3 moles of carbon dioxide is produced. So our ratio is 5 to 3. So when we multiply it by our ratio, we get the amount of oxygen that we need. Okay, and if you think about it logically, the original recipe made 3 moles of carbon dioxide. Now instead of 3 moles, we were putting in 3.3, so just a little bit more. So if we wanted to make just a little bit more carbon dioxide, we're going to need just a little bit more oxygen. Okay, in the second example, okay, we used ratio of coefficients again. Okay, instead we were starting with water. So we knew how much water we wanted to make in this reaction. We knew how much water we wanted to make. So we're wondering, how much of this should I put in? So, and specifically it asks for what mass of oxygen you need to put in. Well, the recipe tells us how many moles to put in. Once we know how many moles we're putting in, then we can determine what the mass of that would be. So that's when we use the molar mass. Okay, and then the same idea applies in the last problem. So if you're given the amount that you're putting in to the reaction, or then if you're given that in grams, okay, we have to figure out how many moles that is. I don't know how many grams of oxygen I'm supposed to put in my reaction. So my recipe tells me how many moles. So it'd be like if you were given the amount of teaspoons that you were going to put into your recipe, but the recipe called for cups. So in that example, you would first need to know how many teaspoons are in a cup. Okay, so same idea applies here. Okay, we know what mass we're dealing with, but our recipe calls for moles. Okay, once we figure out how many moles we're dealing with, okay, when we change our recipe, so in this example, it said what mass of propane is needed to react with 96 grams of oxygen. Okay, so we look back at our reaction. Okay, it says react with because they're both reactants. So if we want to use up all of our oxygen, all 96 grams, we need to figure out how much propane we need. We're trying to use all of them up. Okay, so that's why you would need to go through 3 steps. First, figure out what the amount calls for in terms of your recipe. Okay, then figure out if we're going to use this much oxygen. In this case, when we figured it out, it was 3 moles of oxygen. Then I can say, okay, for every 1 mole of propane, I use 5 moles of oxygen. Okay, so notice if we're putting in 3 moles of oxygen, I decided I only need 0.6 moles of propane. And that should make sense when you look back at the balanced equation. Okay, we only need 1 mole of these for every 5 moles of this. So we need to put in less moles of propane than we need to put in oxygen.